Hello, everyone. In this recording, I would like to give you some homework help with question number 17 from the chapter 9 homework set. All right. I'm going to first read through this question and explain and give you some guidance on how to go about answering this problem. It says here, as reported by the U.S. National Center for Health Statistics, the mean serum high density HDL cholesterol level of females 20 to 29 years old is 53 milligrams per DL with a standard deviation of 13.4. The variable is normally distributed. Determine the serum HDL cholesterol levels that make up the middle 80% of serum HDL cholesterol levels. And we have to provide two answers for this question. One would be the lower level HDL, and the other would be the upper level of the HDL. Now, we start this question by first drawing a normal curve, a diagram. So what I'm going to do is I'm going to draw a diagram of a standard normal curve, right? Begin with the, just a second, this is our bell curve. So we have a bell curve here, a symmetric bell curve, and then the mean will always be located at the center point of a standard normal curve, right? So mu equals 53 in this case for this problem is going to be located at the center. And this middle 80% would be the area around the center point of this curve. All right. Now, because this curve is symmetrical, the middle 80% will also be symmetric about the center point. So I'm going to change the color here and mark 2 points on this curve on either side of the center point. I'm going to extend these 2 lines and show that the area between these 2 end points is the area which is 80%, the middle 80% of HDL cholesterol levels. All right. Now, area is not represented as percentage. Area is represented as decimal. It's a value between 0 and 1. Keep in mind that the total area under the curve is always equal to 1. And when we talk about areas, the values of areas will be a value between 0 and 1 in a standard normal curve. So we have to think in terms of areas now. So 80% needs to be converted to a decimal, which would represent the area. So 80% divided by 100 is 0.8. So the area, the middle 80% of the values have an area or encompass an area of 0.8. That's the area. So essentially what we have to find are the values of these 2 endpoints, that bound an area of 0.8 at the center. All right. So there'll be 2 z values, z sub 1 and z sub 2 is how I'm going to name them. So we need to find a value for z sub 1 or z sub 2 from the z tables. And once we have our z values, we can find the corresponding x values, x sub 1 and x sub 2, using the z value formula that we have all learned. And that will have answered the question. All right. So here we are given an area corresponding to the 80%. So the steps are, when you're given the area, which in this case is 0.8, you have to find the z values from the area. All right. So you take the area and find the z value from table All right, from the z table, you have to obtain two z values. And then once you have the z values, you can find the x values using the formula x equals z times sigma plus mu. All right, and this particular formula for the x value is actually derived from the z value formula, which is, what is the formula for z is equal to x minus mu over sigma. We have all used this formula previously when we learned about standard deviations. Okay, now how do we get these z values? All right, remember the table only gives us area to the left. So somehow we have to know the area to the left of z sub 1. All right, so we know the middle area is 0.8. All right, if the middle area is 0.8, what would be the outside area, the unbounded outside area? So let's pick another color here. So I want to know what the area on each side or each end of the curve would be if the middle portion is or has a value of 0.8. Now these two end areas have a total area of 0.2, right? So these two, this yellow regions, have a total area of 0.2. How did I know that? The total area under the curve is a 1. So if you subtract 0.8 from 1, right? If you subtract 0.8 from 1, you get 0.2. So both these areas together is 0.2, but we need to know the area on each side. Because this is a symmetric curve, each end is going to have a value of 0.1 because it's going to be evenly distributed. All right, so even though the total area of these endpoints, these yellow regions, is 0.2, because it's symmetrical, you can divide it evenly by 2. So each side has area 0.1. So you have to find the z value, all right, the z value whose area to the left is 0.1. All right, and likewise you have to find a z value for z sub 2. You have to find a z value whose area to the left is 0.90. All right, because remember the table only gives area to the left. So z sub 2 has an area to the right as 0.1. However, since the table only gives area to the left, you have to first find the area to the left of z sub 2, which is 1 minus 0.1, which gives you an answer of 0.9, and you have to take that 0.9 to the table to find the value of z sub 2. All right, so you will find your values for z sub 1 and z sub 2. And once you have z sub 1 and z sub 2, use this formula here to find the values of x sub 1, which corresponds to z sub 1, and x sub 2, which will correspond to z sub 2. So that is how you're going to go about solving this problem. All right.